Okay, online people may be able to hear us now. I'm sure someone will let us know in chat if not. Yeah, yeah, the change you need to make to your code should be kind of minimally different. We've kind of stuck to that bit. But what we changed in UFL is firstly, we did some work on the abstract finite element base class. So the idea is that we now have this finite element base class that has these are the functions you need to implement in order to make a finite element. I've not printed them here because there's a lot of them, but it's things like you have to have a cell type, for example, or like a cell object, more likely in UFL. So it has to be an element that's kind of defined on a triangle, and things like that. We kind of define what must be done, and then in basics, we have this basics element class which inherits from this and implements those actual functions. So through this kind of class hierarchy between the UFL base class and the one implemented in basics, we can communicate the information stored in basics to UFL. And that has allowed us to delete a lot of stuff. So this is all in red because it's deleted. So we managed to delete the finite element class, which was actually kind of the implementation of a finite element in UFL. We managed to delete because we don't need to implement elements there because the implementation now comes from basics. We managed to delete this whole file. So this was the file where it was just like a huge file of lists of elements and how they're defined, which, like it says, like here's the name of the element, here's the sublet space it's in, here's the Piola map, and here's some other information. Essentially, that was all information that also existed in basics, and it was a duplication of stuff, which occasionally disagreed, which was really painful. And essentially now that is gone because that information can come directly from basics or from Fiat if you're using Firedrake. And then other things like mixed element, we've also deleted these because they are now handled by the elements coming from basics or from Fiat and don't need to be directly in the UFL core. There was some other stuff that needed updating, so yeah, this I wanted to show you this because this was kind of my favorite pull request ever, where I added 36 lines and deleted over 1,000 lines from FFC. This was when I removed all of the element stuff from the generated code. So there was a whole struct of UFCX finite element in the generated code and UFCX basics custom finite element, which was even bigger, both of which are now not needed because we don't need to write into the generated code, this is how we create the element, because we do the parsing directly. But in order to make this actually possible, we had to do a significant amount of work in DolphinX to do things differently. So the top one here is something we deleted. This is a constructor for a function space. The important thing is here that the first argument is a UFCX function space, which is something that came from the generated code. And because we no longer wanted to write all the element stuff in the generated code, that no longer exists in the same way. So now we have to create it from like a different initializer. And we also had to change this one here. So this one here, we removed UFCX DOF map from the initializer for the DOF layout, and instead have to create it from a finite element within DolphinX. So essentially, like now, instead of passing some generated code stuff in, we have to pass in the elements that we've already handed it from basics that already exists. And then there was a lot of kind of refactoring and other things around this in order to make stuff still work with these new kind of initializers. Yeah, but overall, it means now we're elements kind of much neater. And this is where we're trying to head with the new FL work, is to try and move towards getting the abstractions right, getting some of the implementation into the kind of other components, such as like elements move into basics, and then are communicated properly so we don't have to have this duplication. And it should also mean that it's easier to build new stuff on top of UFL in the future. So I'm going to finish by showing you kind of some other highlights of the things we've done over the last few years while working on UFL. So this is unrelated to elements. This is stuff we did to abstract cell. So this is abstract cell, which I imagine as being like a reference cell. Used to have an init where you'd have to pass in the topological dimension and the geometric dimension. So say you had a two-dimensional triangle embedded in 3D, you'd have to pass in a 2 and 3 when creating this cell. But we realized actually it would be much neater to replace this initializer with some abstract methods. So we'd have an abstract method for topological dimension, an abstract method for geometric dimension, and now you have subclasses that implement these rather than having them passed into the initializer. And this means things like, say you're a virtual element person and you want to build on like pentagon cells, it makes it slightly easier to subclass this and put stuff on top of it. But then a few months after doing this, we realized we could do even better. Because we could remove geometric dimension, because we realized that actually, as far as the reference cell is concerned, a triangle shouldn't really care if it's embedded into 2D or 3D, like elements and stuff would work the same. So we removed geometric dimension from cell and moved it as a property of the function spaces, then did some refactoring to make stuff work there. And so cell is even more abstract because it doesn't need to know if it's in 2D or 3D. And also some kind of, this was one of my favorite things to delete. There was a class called irreducible int, which was essentially just a hack, and it was used in one place. So we removed the hack and we did a lot of other tidying up like this, just to make UFL a bit neater and hopefully then easier to build on top of later. So quickly, the what's next slides. The next things I'm kind of looking at, thinking about are firstly UFL mesh. So in Phoenix, we're kind of starting to think about having mixed cell type meshes. So here I've just drawn a quadrilateral next to a triangle, which is a mesh with mixed cell types. And I think the Fide rate people are looking at similar things. I'm not sure if they're looking in 2D or 3D. We're considering 2D and 3D eventually. And currently UFL can't really describe this because UFL mesh has hard-coded that it has to have a cell type. So we're looking at how to then generalize this. Like, do we have multiple meshes? Does a mesh have multiple cell types? We're going to start thinking about how we could go about this. And then building on top of that, we're going to look at UFL.function space, because again, a function space assumes that it has one domain and one element, which doesn't generalize to this. And also I looked at the initializer, and the first thing in the initializer function space is a dolphin hack with a to-do, which probably should be deleted because it doesn't work with whole dolphins. So there's clearly a lot to be done with function space because immediately the hack needs to go. So if you're interested in joining in with NewFL work, there's a #NewFL channel on Slack, which you're welcome to join and join in the occasional discussion and work on implementation within that channel. And finally, a conference talk wouldn't be finished without plugging some different conferences. So there are two things coming up soon that I am helping to organize. Firstly, there is PD Soft in Cambridge, which is a PD software conference. Registration closes this week, so that's a reminder to anyone in the room that hasn't registered yet that is giving a talk to do that on the 1st and 3rd of July. And because it's in Cambridge, it's organized by the Phoenix people. There will be a lot of kind of Phoenix talk and a lot of other finite element libraries there, so that should be a really good conference. And the second thing I'm involved in, so my other project aside from Phoenix is working on a boundary element library in Rust. And we are doing a free virtual conference for the second year. It's called Scientific Computing Rust, which is those dates online, and you can register for free there if you're interested in getting into scientific computing with Rust because you're bored of better languages. Thank you very much. And do we have time